Hello and welcome to the Microsoft Data and AI South Florida user group. My name is Adriano, your host. Thank you for taking the time and be here with us for another insightful data and AI session. And the Microsoft Data and AI South Florida user group. As a starting point, let us know using the live chat and or the comments whether you can see and hear us well. Also, type in where are you located, the city and the state and the country where you are connecting here today. I am in South Florida and thank you for being here. So remember also to abide by the code of conduct, be cordial to your fellow attendees, to the presenter, and everyone involved in the presentation here. Now, questions. If you have any questions, feel free to use the live chat window where we are monitored during the presentation. Now, if you have a question after the presentation has completed, you can use the comment section below and we will follow up to get your question addressed. Now, today we have a very exciting presentation named Machine Learning ML Prompt Flow. The Copilot is king. Now, it pretty much introduces, explains the prompt flow and provides a broad view about the process. So it's a lot of great information if you're out there. You're going to be introducing also this part two to our previous presentation that Dennis delivered here at the user group. And I'll put a link in the description so you can see if you want to watch that first part. So today we'll be covering, of course, ML, prompt flow, and but who brings that great information will be Dennis Torres. He's an IT professional with decades of experience in technology. He's also an international speaker, user group leader, authoring of many articles, as well as a creator. So you can see the blogs, etc. You check out the description. I'm putting all of his contact information and where and how you can read and contact him if you have any additional questions. Now, without further ado, let's bring in Dennis. Welcome,
Hel-
Dennis.
Hello, Adriano. Good evening.
Good evening. How are you doing?
Fine, and you?
Doing well, thank you.
Great.
So, thank you for being here with us to present another amazing presentation here. So, can you start off by telling us where are you located at? Where are you connecting from?
I'm located in Malta. I live in Malta. Um, During the presentation, I'll show some interesting images of my home place
Ex-
here in Europe.
Excellent, excellent. That's quite interesting there. I'm quite sure, as I know, Malta has some, beautiful sights and great weather.
Exactly.
Uh,
Exactly.
all right. Can you tell us a bit about your professional experience? What brought you up to this moment?
Well, I work with IT since I was 14 years old. It's a lot of time ago. I would prefer not reveal the age.
No need.
It's a lot of time ago. And I always liked the data area, the data platform area, and now we have the AI, and I'm working with generative AI and with some solutions related to large language models, LLMs.
All right, which is kind of connected to today's presentation. All right, so that's very exciting there.
Exactly, it's connected to prompt flow. Prompt flow is capable to coordinate multiple LLMs. So you mentioned this is a part two of a presentation. If anyone here is new to the era of large language models, it's better to watch both presentations in sequence. But if you already have some knowledge about the large language models, what they are, and want to understand a bit more, this is the presentation for you. Because we'll talk about what exactly prompt flow means to a large language model.
Well, excellent. That's a excellent way to get started here, and I will get you continue with your flow. So thank you, and success on the presentation. I'll be right here.
Thank you very much.
All right, thank you very much. And folks, remember, do a like, subscribe, and if you have questions, use the live chat. The presentation is completed, use the comment section below. Thank you. How are you, Dennis? Thank
But by the way, this is Malta. This is part of Malta.
Beautiful.
Yeah. Some of my contacts and information I already talked a bit, but you could take a screenshot of this page. It will be a pleasure to connect in social media. I'm a trainer with some Microsoft certifications and user group leader here in Malta. So, what's the agenda today? We'll talk about large language models and copilots. It's difficult. Sometimes it's difficult today to understand the difference between the words that are being used. And there are many people who mix large language models, think, oh, large language models, we build copilots. A copilot has behind it a large language model. Not exactly, not only that. It's a bit more than that. Let's compare both. Then you understand what's a RAG solution. A RAG solution is the most common solution to allow a large language model to focus on the data of your company. This is what most companies are looking for. Allow a large language model to focus on your data. And RAG is one of the most common solutions for that. Let's talk about the RAG architecture. But RAG is not our main focus. This is more a review. The previous video from the previous session talked deeper about RAG. We'll see an example of a RAG solution, an example built by Onyx Data, the company I work for. In fact, I built this example for Onyx Data. Is a AI solution called Lisa. It's a demonstration solution that we keep on the web. And we'll see some problems that working with LLMs bring to us. Working with multiple LLMs can bring some problems, and prompt flow can help to solve this problem. Prompt flow is the solution for us to advance beyond the LLMs towards the copilot. And we need to first understand the difference between LLMs and copilots. So what exactly the difference? A large language model is one AI model. One AI model pre-trained to focus on some specific subject and may be grounded. Grounded, it means it is focused on the data of your company, for example, focusing on a specific set of data. That's what we call to ground a model. Copilot is not only this. Copilot is much more. Copilot is a flow. It's like a workflow capable to orchestrate between different models, different sources of data to get an answer to your question. So it's not a single model which is behind the copilot. And many people may mix and think that a single model is behind the Copilot. No, a single model is not behind the Copilot. If prompt flow is capable to make this orchestration, that's what we will discover. Let's see an example about this, what I'm talking about. Microsoft released just some days ago the Copilot, Microsoft Copilot. Let me ask some questions to the Microsoft Copilot. Uh, when was Lincoln president? So, Microsoft Copilot gave me the answer. So, he was president uh, in 1861. Okay, good. The information came from Wikipedia. This means the copilot is use information from the web, is pre-trained with the information from the web or grounded with information from the web, or even it may be searching at this moment and getting information. Okay, let's try something else. Uh, could you give me the picture of a playful dolphin? Now I'm asking a picture. There it is. So a picture of a dolphin, an image. Uh, what what part of the copilot? Let's imagine what's behind the copilot. What part of the copilot brought me the answer about Abraham Lincoln, and what part the copilot brought me an image? Who already studied Azure OpenAI knows, for example, that images are created by the DALI model. And there are some specific models used to create image. And these models are not the same models used to understand language, for language understanding. In this way, what the Copilot did, the Copilot orchestrated between multiple models. When I asked for an information, one more of the models answered my question. When I asked for an image, a different model answered my question and provided the image. In this way, a copilot is much more than a simple model, a large language model. No, it's not only that. It's capable to orchestrate among multiple models, and you learn how to do that. Let's first talk about a solution using large language models and RAG solution. What's RAG? RAG is Retrieval Augmented Generation, an architecture involving two parts. We retrieve documents from a specific source, and we deliver these documents to another part of the solution, which will generate a reply to the user question. So when the user asks a question, we need to retrieve the documents that are relevant to that question. Then deliver this content to the model, which will analyze the language and generate a reply. See, the part of the retrieval is extremely important in a RAG solution. It is extremely important because if I can't retrieve correctly the documents which are related to the user question, the model, the AI model itself is not capable to provide an answer because it's receiving the wrong source of information. So the search part, the search capability for the document is essential for a RAG solution. So it's also called as grounding an LLM model. What this means? This means that we are making a model, a large language model, focus its work over a specific set of documents. The answers will be made over a specific set of documents. So we are grounding an LLM model. Feeds an LLM model with your company information, which is what most companies want to do. Azure OpenAI supports many different sources. So where these documents will be, we can choose where we store these documents. Azure AI Search is one of the most used sources because Azure AI Search is extremely capable to make search, powerful search, and deliver to the AI model exactly the documents, the pieces of documents that the AI model needs to answer the question. There is a technique behind this search which is called vector search. Uh, it's we usually say that we are create embeddings of the documents. We create a mathematical representation of the document and we store these embeddings or this vector, and we make a mathematical search for the documents related to the subject the user is questioning. So vector search is an essential component to make this RAG solution work. Because if the search fails to deliver the correct documents to the model will give a wrong answer. So here we see the feeds of that OpenAI support out of the box. OpenAI, I mean Azure OpenAI services supports receiving documents from these sources. AI search is very used. Some search, some sources here, like Azure Blob Storage, URL web address, upload file, are only wizards. It's not possible to use directly a blob storage for that. What it does, it uses a blob storage, but in the end, use AI search to get the data. If you give an web address, it will index this web address and use AI search to store the data. If you upload files, the content will go to AI search to store the data. So some of these options as source of information are just wizards. Isn't. CosmoDB is capable to use vector search and is capable to be the search for OpenAI as well. I don't have large experience with using CosmoDB or Elasticsearch for Azure OpenAI. So let's talk about the RAG architecture. The format of the RAG architecture is always very similar to this. And it's used to access unstructured data, unstructured information. This is the solution to access unstructured information, like PDFs, Word documents, and so on. In this way, we have a backend and we have a front end. The backend is the responsible to ingest content to be used by the model. So we have the cognitive services search. This is the old name of the AI search, Azure AI search. In the past, it was called cognitive services search. So the backend is responsible to feed the AI search with the content and create vectors for this content to allow the vector search, while the front end is responsible to get the user questions and search the content of the AI search to find the relevant documents and provide an answer based on these relevant documents. Of course, there can be many variations of this architecture, but basically that's what we need. We need a storage with a search capability for the content, and our AI model will need to receive the result of the search on this storage. There is a tool provided by Microsoft called Chat with Your Data Accelerator. This tool has this entire architecture ready to use. So maybe you would like to use this tool. It's a great start point for RAG solutions. Okay, the list example. Let's see the example built by Onyx Data, which I built by through Onyx Data. It belongs to Onyx. So we have two solutions here. We have one chatbot to ask questions about structured data and one chatbot to ask questions about unstructured data. In the side of the structured data, I ingested a set of information about regions in Europe, cities in Europe. Is a model called NUTS, Nomenclature of Territorial Units for Statistics. This exists, it's called NUTS, and is available in this location. So I ingested this and I asked questions about this model. On the unstructured data, I ingested articles about data platform and about fabric, and I can make questions about that. Let's see a demonstration about this. It is, sorry, it is here. Let's start with the unstructured questions. What's Microsoft Fabric? Liz is checking the model. Since we don't use all the time, it's waking up the model to answer our question about what is Microsoft Fabric, and it provides an answer about the question we asked and give us the source of this answer, an article published in Onyx Data portal, providing us the source of this answer. Okay, this is how a RAG solution for unstructured data works. And if I ask a question about structured data, we are using the NUTS model. So I ask a question. Could you show the total of islands by country? Ask. So it's processing the question over the data. And there it is, the total of islands by countries in the European region. The answer that we asked. How the structure part works. How the structure part works, the relational model, this relational architecture. I have a front end, the user makes the question, I have a lakehouse, and I have a model, an AI model. I explained to this model the structure, the modeling, data modeling that I have in the lakehouse. What information I have there. And I didn't give the model the information. I explained the modeling of the information and I asked the model, please generate a SQL query to answer the user question. And that's what the model does. The model generates a SQL query to answer the user question. Then I need to go to the lakehouse, execute the query, get the answer, and show the answer to the user. A model very different than the RAG. We use the RAG for unstructured data. For structured data, we need to use a different solution. If you try, for example, to ask structured data questions to the RAG, it will not answer you correctly. For example, what was the total amount that John ordered in our company? Although the reg has many information available, it may not be capable to sum out the total amount that John ordered. And many questions related to data are not good for reg. They are more for a relational model. The point is, I just simplified that Lisa, for example, has two models, has a relational model and has a non-structured model, a RAG model for unstructured data. And here we get to the core of this session. How to unify the two UIs in a single one. What if I want a single UI where the user can ask the question and we decide which model will give the answer to this question? In this case, we'll be building exactly a copilot. We'll be building a copilot because the copilot will be orchestrating among multiple models in this example. And it's very common that we can use an AI model to make the orchestration. We can get the user question, send the user question to an AI model, and ask that AI model, okay, I have these two models here with different capabilities. Which one is the best to answer this question to the user? So the AI model itself tells me which model will best answer the question for the user and defines the flow of the orchestration. So prompt flow to solve this problem. Prompt flow is a workflow system coordinates among multiple AI activities. So we build a workflow of AI activities. To answer a user question, we can build a workflow containing multiple calls to AI models to take decisions, follow the flow, transform the results, transform the information, and then provide the final answer for the user. We can use Python code to automate the activities. Part of these activities can be using Python code. And the result of an activity becomes the input of the next activity in a workflow. It's a workflow. So the meta prompt flow orchestrates multiple LLM models. Establish a workflow between multiple LLM models. For example, here is getting an input, classifying the input, defining what to do with the input, following a flow to generate a result, following a specific flow to generate a result. Okay. And this other one is exactly the Lisa example. This is the Lisa example. Just a moment. Let me Be sure that I open my Zoom tool. So the list example starts categorizing the question. What kind of question is being made? Is a question for structured data or a question for unstructured data? And then each side advance with the tasks that it needs to be done. For example, on the unstructured side, we search for the documents, we understand the search result and build the final result. And with this structure area, we build a SQL, we call a function to build a SQL, execute the SQL, and then with the result of the SQL, I can pass the result of the SQL by an LLM again. So I will not show the result of the SQL only as a table. I will show the result of the SQL as a natural language answer to my end user. This is the flow of Lisa. So activities that we can create inside prompt flow is like we create a workflow. We can use any one of these kinds of activities. A search in an index, create embeddings. Embeddings are another name for the vectors. Make a call to an open model LLM and so on. We can use all these activities inside the flow, including a Python activity. So if I can use a Python inside the flow, I can develop pieces of the flow. Let's see this working. Let's see how this works. So here I have the flow. The flow starts with input parameters. The input parameters of the flow is the question of the user. And when we create the flow asks us if we will build a chat history or not. If you want this chat to have a history or not. If we want to, it will give another parameter which is the chat history. So we start the flow with these two, let's say, variables. These two variables. Then we start creating the tasks of the flow. But let's understand this. The user question, but the user needs some UI, a bot to type the question. Yes, yes. This flow can be deployed in a series of virtual machines, in a cluster of virtual machines. And we can call this flow sending the user question to this flow. So this flow, once built, can be deployed in a compute hardware, compute set created in Azure ML. So let's see the first task is to categorize the question, define if this question is a question to be answered by the structure area or by the non-structure area. So categorize the question. There is a connection to OpenAI is calling an OpenAI model, and I'm defining parameters for the call to the OpenAI model. And I'm defining the prompt about what I want the OpenAI model to do. Classify the question. If the question is related to data platform or is related to European regions and countries. So I'm asking it to classify the questions. And we are using chat history. So I put as a context the history of the chat as well. And see, this is a special syntax to build the prompt that is being sent to a model. Then I will have the result. I will have the result which here final result, the output coming from the result. And I have the category output, the output of this task, categorized question is the category. Okay. So the input is the chat history and the question. I'm using the two inputs that I have on the top, and this transforms these inputs in variables that I can use here. The inputs and the chat history, and the user question. Then, according to the result of the previous one, we will go to two different flows. Or the next task will be build SQL, or the next task will be a search in documents. How do I know what will be the next task? Well, on the tasks, I have the activate config configuration for activation, and I'm putting here a, a condition for this activity to be activated. This activity will be only activated if the category is European, if the output of the category task is European. So, in this case, this question is a question about non-relation about relational data to be searched in the relational database. This is a large prompt which explains the model I have in the database to the OpenAI model. So basically, I'm asking OpenAI to build a SQL query for me. Okay. Then I have a Python script that will execute this SQL query. So this Python script, in fact, I don't execute directly in the Python script. I call a function, and the function itself execute this query over my data. I don't need the condition anymore because this depends on the first one, and the first one had the condition. And after getting the result of the query, I use the result of the query, the execute SQL output here, execute SQL output, uh, as a context to another model call. So I'm asking to this model, as a data analysis specialist, use the data in the context to answer the user question. So I give the user question, I give the data which answer the question, and the model only needs to structure the answer to make a good structure for the answer. Okay. And now we start with the other side of the analysis. On the other side of the analysis, the activate config is if the question is about data platform. In this case, it needs to search in unstructured documents to answer the question. So I'm configuring search documents. This is a search in AI search index where I'm defining the question and asking to search about related documents using a hybrid search method using vector and keyword search at the same time. So the result of the search comes to this translate search result. Why? Because this is making a call to AI search. The AI search answers the call with a JSON result. So I need to get this JSON and interpret the JSON, guess really the content of the documents which are relevant to the model. And once I translate the search result, as I defined the name there, I get this translation of the search result and send to OpenAI. Send to OpenAI as a contest to answer the user question. So you notice we have the user question, chat input is the input question from the user. We have the history of the conversation with the user, and we have the context coming from the AI search. We give this to the model for the model to make the search for us. After that, we build the reply. We are basically getting a custom prompt. This previous task was basically to build a prompt. We have an item here to include the task here to build a prompt. That's what I was doing. I was joining the information to build a prompt, and when calling OpenAI, I can just get the output of the task to build the prompt. And in the final result, I need to decide, I use a Python script to decide what was the answer, was from the structured side of or the unstructured side, and I decide which output I give to the end user, from the structured side of or the unstructured side. I can test this. This is the Azure Machine Learning Studio. So we have a machine learning workspace, and I'm playing on the Azure Machine Learning Studio. So I can chat with this guy and ask questions. What's Microsoft Fabric? So it's executing the flow, analyzing my question. What's Microsoft Fabric? And providing the answer. Providing the answer from the AI search. Could you list the total of islands by country? Now I'm using the other side of the flow. So I'm using two types of questions. One question is an unstructured question, which needs to come from one source. The other question is a structured question, which needs to come from a different source. I'm using both together in the same environment, in the same chat window. This means now I built a copilot. Now I built a copilot. I built an orchestration involving multiple large language models.
Wow, Dennis, very cool here while we're waiting here. Can you hear me?
Yes?
All right. So at this point here, what we see is pretty much as you outlined there, you have the structured data and the structured data. If I'm not mistaken, I think that is that the Microsoft Fabric?
It is stored in a lake house in Fabric.
All right. So you are able to go leverage the Fabric service, and then the other one you have the unstructured. I think the one relates to the islands and the European Union information there, right?
Exactly.
So you're primarily purely just use your own data without going outside and everything.
Exactly, and I'm orchestrating to get the best from all the data, to get the best for the unstructured data that we can have, and get the best from the structured data, and in the correct way. If I mix the type of the question that I can make to each one, I would get better answers. If I get a question that should be done to a relational model, to the unstructured model, I will get bad answers. How am I so sure that I'll get bad answers? Because the retrieval part of the model, of the RAG that I was explaining before, is not fully language aware, is a mathematical process. It gets documents related to that, but it may not get the documents related to the data that I'm asking about. And will deliver that to the model, and the model may not have the answer to give to me. So the retrieval will fail if I try to use a non-structured model to answer a structured question. But using the prompt flow, we can have both models orchestrated and coordinated in a single flow, which is now what we can call a copilot, orchestrating multiple flows. That's why the title of this session, Prompt Flow is the copilot's king. We can build a real copilot orchestrating between multiple flows, multiple models using the prompt flow.
Awesome. That's very, you know, comes very useful there regarding taking that information and principally the internal part, as you said, then taking using the multiple models, bringing in prompt flow to do the orchestration, regardless whether it's structure or unstructured. All right. And folks, do you have any questions? Use the live chat. Let us know. How do you like this information here? Do you see yourself using that on your organization or maybe even propose or as a project? All right. That is all you. Thank you.
Thank you very much. Let me leave some reference. Um, so here I leave some reference to the attendees. Um, the previous video that I delivered exactly to the source log, the user group, about how to build a RAG solution. On the previous video, we focus on a RAG solution. Now we are focusing on orchestrating multiple RAG solutions. I mentioned in the chat with your data accelerator is a good start for who is starting with a RAG solution, and an article about prompt flow. So you have these three references that are good reference to uh, to master this subject. So thank you very much for attending this session. Any questions?
All right, folks. Great presentation here by Dennis, bringing in and enlightening us about the entire process here, using our own data, leveraging Azure AI. He also touched Azure Machine Learning, and he starts diving deeper into it. Whether we are using structured, unstructured data, So let us know your questions. What are your thoughts here? How do you feel about that? Hey, we just got a comment here from Pablo. Thank you, Pablo. Pablo saying thanks. Very interesting, that Dennis.
Happy that you like it, Pablo.
Yes, and
Good to know.
Pablo, he is from Argentina, our former neighbor back there.
Ah, yes, our neighbor.
All right, Pablo, thank you very much there. So, folks, let us know. It's extremely interesting. You can see as well the direction where things are going. We see here when we do all the work here with the data files, and then we're starting to interacting with it and bringing in, leveraging Microsoft Fabric as part of the process there. Azure Data Lake Storage or some other storage locations. So you see the entire ecosystem coming together and then tying with Azure AI, Azure ML. So some very
Exactly.
exciting things there. So let's see here. In the meantime, if you have a question, let us know here. We are, the last minute here. Thank you very much,
Mm.
Dennis.
I leave my contacts as well, and it will be a pleasure to stay in touch in social media. And any questions, we can get in touch. Any help, we can provide.
See, folks, also, as Dennis just mentioned, that's his contact information. Check out his articles. He also has a YouTube channel, some great information on this. Drop a comment as well. Show that you like it, you know, to the community, let others know. So share the presentation as well and come back and review. I know there are a lot of information here to be digested in one time. So come back, check out the pieces that you see, try to play with it to an extent of addressing some of your interests there. You know, this fantastic information here being shared by Dennis. So, Dennis, any final thoughts here?
Um, it's interesting too that there are lots and lots of solutions uh, that make people confused because people see articles with 10 different solutions and don't know which one do I get. Uh, the point is, all of them may have the same architecture, the same structure, suggesting you that you use the technology in a bit different way. Starting from a RAG solution on a large language model and ending up with a prompt flow orchestrating multiple large language models, how we did during these sessions. So the lots of models, they all may involve a similar solution like this.
All right, all right. So this becomes kind of a framework there. The starting point is a reference point. That's it.
Yes, an architectural reference point related to RAG and related to machine learning prompt flow to build copilots is a starting point. You see some difference, some technology difference in one architecture, in another architecture, but now it's easier to choose.
Excellent. It, thank you very much, Dennis. Just
Welcome.
hang on tight just a little bit here as we come here to an end. So, folks, hope you all enjoyed today. ML Prompt Flow Copilot is King by Dennis Torres. Fantastic presentation. Hope you all learned a lot. Stay tuned. We'll be having our December presentation. Will be announced here in the coming week. Also, some very exciting, very interesting, and insightful presentation being brought to you by the Microsoft Data and AI South Florida. For all of you there, thanks for your time. Thank you, Dennis, for your time as well. We look
Thank you
forward
very much.
we look forward to see you again next year in the group. We continue those amazing presentations, whether in our group as well as other great community user groups that you are out there participating, as well as leading, as you mentioned, the Malta group. And folks, for that information, check out the description section below. You'll see his references and his contact information as well. All right, folks, you all take care. Have a great day there.